Ready? Okay. Hello, everyone. My name is Sammy. I'm one of the board director as well as host for Kari's session today. Today we have a Kari on our panelist. He's our keynote speaker. I have known Kari for a number of years now. Kari Kakkonen has worked in software testing for almost 30 years now.
Hello?
Hi, can you hear me?
Yeah.
Okay, good. He is a service owner of customer expertise development at Go4. He's an author of Dragon's Out software testing book and also co-author of the Act to Lead software testing leadership handbook. I would like to get a copy of that book at some point. He has won many awards. One of them is a Eurostar Testing Excellence Award in 2021. He works mostly in agile testing, lean and test automation, DevOps and AI. He has been active in ISTQB. That is where I met Kari, TMMI, Finnish, and also the Finnish testing board. Kari, I'll let you take the stage.
Thank you, Sami. Pleasure being here. So let me share. Here we go. And now you should be able to see it. Yeah?
Yes,
It's
yes.
there. Super. Okay, so my topic on the next 40 minutes is how AI supports software testing. So let's go. I'm joining everybody for my LinkedIn. If you want to be part of my network, you have it there. And then on the next slide, we have some information on agenda. So I'll just very briefly give an intro on why AI. Then I like to show where I got interested in AI, and let's say a NASA case. So I'll just give a very brief one on that, and then most of the time will be spent on thinking about the AI opportunities for testing. So lots of different ideas there. Well, let's go there. Good. The slides include my background. You'll get them later. As you know, I'm man of many hats, and Sami introduced me nicely. My first hat, Go4 hat, where I work full time. My book hat with my Dragons Out book, taking testing to children, and my leadership testing book, Act to Lead, another hat. I'm also ICQB active even after all these years. It's always pleasure working in a big organization like that, and TMMI hat, and so specifically here my hat is the secretary of the board of directors of TMMI Foundation. So that's based in UK. Well, I'm based in Finland, but still, we are very global and work in different places. But let's move to the actual topic. So why we need AI? That's the question. And why AI in the first place? So why is it happening now? And now meaning past 10 to 15 years, and of course increasingly these last 2 years with the ramp up of generative AI, Gen AI, with your chat GPTs and so on. I will mention those a bit later as well. So why now? Well, world is ready for it. I think that's how you could say that. So computers have finally enough computing power to do things with AI algorithms. There's also enough data because most of the AI, not everything, but most of the AI is actually machine learning, and machine learning requires data. And now we have data. It used to be called big data. Now we just have lots of data, I think, and that can be used for machine learning. And then, of course, we also have an increasing community on AI algorithms, and that's very much open source, very much community based, and then that means more and more companies can pick it up, and also you have your frameworks and so on that can utilize all this. So these things are happening side by side, and AI is now happening. And how about testing then? In software testing, can we somehow do without AI? I don't think we can. And there are also multiple reasons why we should look into AI's opportunities, whatever kind of testing we do. So software complexity increases, and software in the world in general increases. And these two factors just may make it impossible to keep up with any traditional ways of testing. So test automation included, manual testing included, even exploratory testing, which would be my favorite way of testing, which is quite fast way of testing, but that's not fast enough. And so speed really comes from the increasingly competitive market landscape. So the time to market requirements are so quick and short that we just need to be faster. And also the culture of continuously delivering, so DevOps culture and your technical pipelines, CI/CD pipelines are there also demanding testing to keep up. And that's increasingly difficult without AI. And then you have also AI software that are so complex that they actually require also AI testing to help there. So there's lots of reasons why. And it's very big time. It's mainstream, I think, now. And Gartner here calls it AI augmented testing. And I'm thinking like this: if Gartner has named it something, whatever, it is mainstream. So I think this is proven now. AI augmented testing is a mainstream thing. So that means AI can help testing in a number of different ways to have better quality and faster. My summary of AI augmented testing. That same Gartner study also provides this very interesting way of different testing eras. And you notice that the last one is mentioned as AI augmented testing. And that really talks about the shorter delivery cycle times, and at the same time increasing complexity, and which I mentioned in a few previous slides. And that requires more testing efficiency, and it only can happen through AI being part of testing. So that's where we are. We have this need, and we just have to deliver somehow. Let's go to the AI and in a NASA case. So why NASA case? NASA has, of course, um, done lots of good for our world, and taking us to space and everything. But they also have released lots of nice stuff, including different open sourced data. So data that anybody can use for learning and testing and trying out and so on. So we are taking a look at different algorithms that can be used using that data. So that particular data set includes different code quality metrics on a number of NASA software, and those metrics are quite conventional. So, for example, lines of code, encyclopedic complexity, which you can see there, but also some 30 other different code metrics on the same software. And so all of these on their own are not really that good in predicting where problems might be in any software. You can say that okay, more complex software, more likely it is that it has problems, defects in it, but that's actually not even fully true. But if we actually combine a number of different metrics, and this you can do with AI, and it was done in this particular study in 2005, so that's actually 20 years ago already. In that study, they took the NASA data and they taught an AI. So you have used the machine learning algorithm with the type of SVM, so that's support vector machine, and that sort of machine learning can learn and create a recognition of where a defect might be. So which of particular modules in the software might be defected. Based on trying to understand those different metrics that were given to it for learning. Basically, it's a multidimensional hyperplane that this AI model can create, and then if you give it a new piece of data, it can say that, okay, more likely this is going to be a defective model. It has problems. You should look at it more, or not. So this accuracy, how good prediction this sort of AI model can give, that accuracy is what you want to have as a good accuracy, or here it's called performance. That's an AI term. How well it performs, and you notice the performance is 0.6, and that's really high compared to any of the other individual predictions from those individual code metrics. So already here, it's proven 20 years ago that AI can predict much better than any individual code metric. So that's lovely. So seeing that many years ago, my AI journey started, maybe, was it 10 years ago? Then I saw this study first, and that was just an eye opener. You know, these things can be done, and that's amazingly efficient. So let's take a look at different ways of how AI can help testing. So some areas include, let's start the first one, anomaly detection. So what does that mean from tester point of view? How can I find defects faster? How can I identify somewhere as a problem somewhere? How can I do that? Maybe I have lots of defect reports. How do I know which one is more important? If I have duplicate reports, how do I know if there are any or not? These kind of problems are quite typical for AI. So and what AI does there is that it uses anomaly detection. So it tries to notice something that is different from rest of the data. So if you have lots of defect reports or lots of anything, lots of different similar test cases or test runs or results, it can notice what's different, and that different might be a problem. That might be then a defect if you analyze it more. So that's anomaly detection. So let's have a case here. This case is using Windows and Firefox automatic reporting of crashes. And in this example, first you need to create a model. So a model has been created using that crash data and the classification if some crash was a severe crash of the system or not. And then after teaching, what happens is that, let's go to the next slide. After teaching, what happens is that you can use a model and give it any new crash report, and it can immediately tell you that this is likely to be a problem. So when you are getting millions of crash reports, it's quite impossible that any human being can go through those one by one and decide, okay, this is going to be a problem now, that's not so crucial, let's forget that. What you have there is a tool that can go through all those crash reports automatically and just use a model on it and then say that, okay, this is going to be the top traits, these are the high priority problematic areas. Let's take these under consideration and do some improvements on the software so that it wouldn't crash so often. So that's defect prioritization for you as a tester term. So anomaly detection, quite typical thing where AI is used, and that's how it's used for testing. Another typical AI capability is prediction. So how do we predict that something is good, something is bad, something is priority one, for example? These questions turned into tester objectives are basically, if I have lots of tests, which test should I take first? Or if I have only a little bit of time, in which order should I run my tests so that I can get most out of my limited time? Or you could expand that into, so if I have these 10,000 tests or 100,000 tests, do I actually need all of them? Can I prioritize them somehow? Can I predict somehow which ones are more important? So they would be my priority test cases. Or you could look at different parts of your software and decide, okay, which ones are the important parts. So what happens there is that you give all kinds of data that you have into your AI tool. And all kinds of data needs to be different versions of the source code, different code quality metrics on those source codes, requirements, so information about what was software all about, tests, test runs, and also defects. So, and whatever tools you have, you need to connect this thing together and have your AI tool crunch through that data, and then you can give different AI proposals to different stakeholders. And depending on what kind of a stakeholder you of course are, you need different proposals from AI. And I'll just pick here 2 examples. So first of all, if you're a team member, most likely you want to understand which parts of the software are problematic, where might you want to spend more time removing technical debt or fixing actual defects, or just improving test coverage because it's so crucial part of your software. So this would be something that an AI tool typically can do. If you are in management, you might want to know when can I release? How close is this particular sprint to being ready? And do we have big problems? Where are these big problems? And again, by having an AI-enabled tool shifting through your data, it can propose that, okay, take a look at that module. If you fix that, then you are probably quite safe to release the software. So let's take some examples, and in the next many slides, I will be taking many examples, and on purpose many examples. I don't want to promote any one software tool, and true is that there are so many testing tools these days that have already AI in them, and I would even say that all of them will have AI in them if they don't have it yet, and that will be very soon. First example here on this type of use of AI is on predicting quality issues. So this case here, Eggplant does exactly that. So it goes through data of your software team, looks at different functionalities, and then tries to identify based on that learning that, okay, where are the risky areas, which have a likelihood of having defects again, or which are maybe so crucial that they are risky because they are so central functionalities. And then it proposes, why didn't you do those tests first that are related to that functionality? And even for I'm now saying, okay, this is what this software does. This is just an example of probably just one side of this tool suite. So all of these tools mentioned have many sides, and of course they have been evolving since I've probably taken a look at this particular software. Another a bit similar example, App Certify case, but different, focusing more on trying to reduce the number of test cases that you need to run. But similarly, it is a prediction thing. So you give lots of data to the software, and the AI part there analyzes which parts of the software actually have risky areas, which tests are linked to those risky areas, and so which tests you actually need to run. So the simple idea is that let's test the risky areas only. Simplified quite a bit, but that's really the essence of it. And here also you notice human beings could do this as well, and good testers do it, but it's so much faster if you have an AI tool doing that, especially if your software is very large and you have lots of tests. Next example here is a code analysis tool, and so a bit like the NASA case, but this one is live and much bigger. And this one is also interesting because it's really um, based on an open source community of developers exchanging ideas, asking questions about how do you code this, how do you fix that, and all these improvements and discussions are used as um, a learning for the AI model, so that the AI model then can propose what to do if you give it a piece of code, and how do I improve this? Well, for example, like that, and all of this is coming automatically based on the AI learning on so many developers collective and knowledge and wisdom. So that case is deep code AI. Okay, let's move on to the next area where AI can help testing, and this area I call fault tolerant test automation. So here the tester's objective is that when you have test automation and the SUT is changing, what tends to happen, of course, is that your test cases, your test scripts are broken, and you need to fix them, you need to maintain them. And of course, any test automation expert is always feeling, how can I make my tests pass a bit more often with less maintenance? And if you take that thought further, you can think, okay, can I maybe use my existing test cases to something else, other type of software which is similar enough, so my test case might work? Or could I even use somebody else's test cases, test automation scripts running for my software, and I don't need to create my own scripts? Is that even possible? So if your test automation is fault tolerant enough, that is actually possible. So let's look at a few examples again. This one is approaching that problem from the idea that it takes an existing set of regression tests. It learns that, it checks how that particular test in that test set is actually recognizing an object in a graphical user interface. And of course, you can identify those objects in different ways. It could be object ID, it could be the text, it could be the location, it could be a visual difference or visual image recognition. And basically, it is then noticing the optimal way of recognizing any particular object. And then if and then the SUT changes, it can propose that, okay, I can do the same thing, same recognition of this object on the screen by using something else, and then so it self maintains the regression test case, that test script, and obviously that's very nice. For tester, you don't need to maintain tests that often. Also, this is a nice case which I like to have it here on this slide deck, is because this is an example of a company that actually already went bankrupt once, many years ago, maybe 4 years ago. But because the idea is so exciting, it immediately found new funding, and it was started over with the new management, and it's a big success. And I say 4 years ago because you remember when Gen AI started, ChatGPT came out. That was 2 years ago, and that timeline is very big in funding. After that, everybody started looking into AI. Before that, AI was already a big thing, but funding was not that easy to get. After that, Gen AI entrance into the world, suddenly everybody gets funding when they want to create something with AI. That's good. Next example is what AI can do for model-based testing, and here the case example is Confirmic. I'll keep it short because we'll have actually Confirmic talk a bit later. But basically the idea is that once you have a model, from model you can create test cases, test scripts for automation quite automatically. But if you combine AI into that model, you can get better, faster test coverage. And it's a type of AI called symbolic AI as well, which is quite interesting. So not everything is your pure machine learning. AI has actually many different ways of working. Let's move on. This example is again very different from others. So here we also enter into open source world. So lots of open source test scripts are done with Python. It's scripted with Python, and many Python test automation experts like to use PyCharm editor. And if you want to make your test automation more effective there, you can use AI libraries. So here's an example of a library called DevTools AI library. And this sort of a library is semi-automatically proposing where to change your test script when the SUT is changing and your test case does not pass anymore. So it's not changing it automatically like the idea of retest was. It is proposing that with this very quick change, you can make it work again. So if you want to reduce the number of hours you use on the maintenance, this is your choice. But you still need to maintain your test scripts as a test automation expert. Let's move on. Again, very different idea of how your test automation is more fault tolerant. And this one is more black box approach, which is also say here new life for record playback. And so, which would be your 90s test automation tools. Even for, those functionalities are in test automation tools also these days. But here, when you couple that idea with machine learning or AI, what you can do is that a tester or user is just using the user interface, and on the back, AI is actually recording everything, and not just recording, but actually creating maintainable test cases that it can then run and keep running and fixing and running without human beings really doing anything. So it's learning how that user interface is working, basically. And again, that's a big promise. And I think here with this message, I can also say that beware of big promises. Make sure, try these tools before you trust them too much. I'm sure Functionalize is a great tool, but I would also, if I would try it on my own project now, I would evaluate how good it is in this promise. But great idea, and this is somewhere the world is definitely going. Next different kind of idea is that why don't you replace your typical way of recognizing an object on the field, which would be getting the object ID or the name. Those are probably the most two typical ways of recognizing objects. Why don't you replace that with recognizing pictures? So a human being testing a graphic user interface would just see that there's a button there. Button might say OK. Okay, I can see there's a button OK. And even if it differs in color in the next version of SUT, or maybe it changes the place on the screen, I can still find it. It's there. It's a button, OK button. Doesn't matter where or what color or what font type. So how can I make my software testing recognize it in the same way? Well, you use an object recognition library, AI library, that have been taught with all different versions of OK buttons in the world. And so all you need to do is your test automation script, click the OK button, and it does that. So this is a nice idea. Again, it's also from open source world. So these kind of libraries are available to anybody. Let's move on. This case is looking into the process of where do you exactly use test automation and where not. So where do you use AI in test automation process? And you notice that actually you can use it in many places. It can help in creating tests, it can analyze the results, it can propose kind of self-healing problems like we talked earlier, but it maybe can't, in this case, it can't really automatically fix all the failing test cases, but it can propose and again make maintenance less heavy. And so I think AI assisted test automation or AI augmented test automation really is going to be more and more effective or efficient in next few months and years, taking all these different AI tools into your test automation set. So this is kind of an overreaching idea here. Let's move on. We have an area called AI assistance, and so this is a bit different from previous item because it also covers manual testing. So here what the tester would want to do is be faster, be more efficient. It could be trying to create a test automation script for first time, but doing it faster, or manual test case. And or it could come from other way around. Yeah, after people hear about, oh, where's Gen AI, oh, there's LLMs, and so on. How can I use it also? This is what many testers these days think, and it's not a bad idea. You should look into AI because you have heard everybody else is using it. But so how can that happen? Again, there are different types of AI assistants that can be used with your favored editor. So again, this is Python editor example, but the library here is different. So Refact AI library, which is based on ChatGPT. But the nice thing here is that it actually understands your typical test automation setup, in this case, Python robot framework test automation setup. And then it can propose you your pieces of test automation script automatically as you go and type your stuff. So that's, increasing your speed like double or triple. And that can be a big help. Of course, this kind of thinking maybe even started with GitHub Copilot. At least for me, this was the first eye opener of this type of software. So if you like to use GitHub Copilot, this is what you can do. You just type your test automation script, and basically this software in the same editor. So you don't need to open any other software. You don't need to copy paste from any other place. You just type in your editor, and it proposes you, okay, maybe you meant this, and I mean, you just review that and you approve that, and it's there. And when you go to your next line in your script, and so you move forward until you are done with your script. And again, basically, it makes you 2 or 3 times faster. So GitHub Copilot is a really cool thing. Well, that takes us to the chat-based tools. So Gen AI in a chat format. Again, you have lots and lots of choices all the time, more and more coming up. So let's just take for European point of view the Le Chat from France. Here as an example. So what you could do is open that, give it good questions, like here's my requirement. I would like to have 5 test cases out of this with this format, curriculum format. Please do it, and then you have it there. And you can say like, oh, I don't like a 5th one. Please make me a 6th one, and then it again does that. And all these tools work in a similar manner. So you need good prompt engineering. You need to review them, and then you can copy paste it to wherever you are running your test automation or doing manual tests. So that's also useful. But at this point, I think I'd like to make an efficiency warning. So even though all that I said previously might sound very good, there's actually a danger that it's not in a big picture that efficient. You might end up fiddling and reviewing text, and if you count your hours in the end, you are not saving time. You might even be losing time. So it depends how you do it, but just be careful there. There's a good article about that. AI maybe not being that productive. And in general, you might end up in problems with confidentiality, privacy laws, different confidential data that you are not supposed to give to anybody else. So your company definitely needs policy on how to use AI in your software development and software testing work. And after you have decided how you can do it, you need to prepare your AI environment. So maybe you don't use your ChatGPT online. Maybe you prepare a local instance of that LLM in your own computers, and then you don't need to worry about your confidential data leaking out into the world. Whatever it is, however you do it, have some AI policy. Okay, moving on. So if you have that kind of fault-tolerant test automation, if you have that kind of power of quickly creating tests, what can you do with those tests that you already have? Well, you can think about, let's take a middle point there. Can I just leave my testing for AI? Can AI, run my test once I have created one once? Can I just leave AI to do the work? Well, in a way you can, and here. First case is a mobile test automation platform case, which actually has changed now. Just check the links earlier. And basically the idea is that if you have similar enough software, like mobile user interfaces quite similar, you can have a set of test automation that can be run anytime, any software, doesn't matter which app it is, but you can always start with the standard set of test automation scripts run by AI. And they will find most of your defects. You probably need to add to those tests later, but then that's fine. You have saved time. Another example, open source volcano example is what you give different types of test automation scripts to a tool that creates bots out of those scripts. So the bots will be running those test automation scripts all the time to different versions of your software and finding different kind of problems and defects there. So you could even call that autonomous testing with this example. Or you could just take the whole idea into digital twins and run hardware in a digital twin, and software will be run on that hardware and run those tests run by AI. And so it would be really automated. So I call it here AI augmented test automation solution. Okay, and this takes us to a few final points, which is where can AI be in your testing? And here's lots of text in a picture, but you can already see that the gray areas under the boxes are AI. So AI is actually everywhere. In any part of your testing, you can use AI. Some of it will be Gen AI, so we black text there. Some will be AI tools, like ones I talked, red text there. But you can actually use AI in any part of your testing. A few resources here for your further reading. Let's not go into these now. This neither. But this one I'll cover. Just very briefly saying that Timmermeier is also looking into AI, even asking questions in surveys. This was 23. How many companies are using AI and testing? So at that point, not that many. But the big thing is that Timmermeier is also recognizing that testing AI systems is different. You need to have more different kinds of testing. And also that, like I discussed earlier, AI can be used in testing, almost any type of testing. And it can be part of your systematic journey of making testing better. Maybe your next step in test automation, like I mentioned. Recognizing that AI is kind of a different type of software, and that gives us more challenges. But you can implement that with Timmermeier. It's also, and here are some nice examples. But I will leave these. This is not the focus of my talk. Just leave them to you as a further reading. And here you notice I tried to ask AI in pictures the summary of my talk, and didn't really work. Nice pictures. Summary flow is that with AI you can focus testing on high risk areas. Your testing will become more autonomous, and your testers can be creative, do more tests. And if you haven't started your AI journey, you should start today. With that, I am done. Do we have any questions? Sami, I can't hear you.
Okay, can you hear me now?
Yeah.
Okay, thank you very much, Kari. So it was wonderful to understand how AI and testing can coexist and help each other. I have a very quick question. We are running out of time, but I will ask very quick. Are you concerned about AI being trained with incorrect information?
Absolutely. That is one of the first things you should be concerned, and I am very concerned about that. So testers' attitude, of course, helps there. So you need to look into how the learning data is chosen. Is it ethically chosen? Is it balanced so there's no bias? So those things really need to be considered. And actually, testing AI is really looking into data much more than looking into the actual software.
Okay, good. Oh, yeah. So, yeah, we have to keep an eye on that. So what's the current state of AI in testing then?
I think it is becoming mainstream. So any tester is thinking about AI these days, I think. Most testers are. I don't think most testers are yet using it. I see and talk to lots of testers, so not everybody is actually doing it, but it's like it's the interest of this year, definitely. And I think if you look back next year, everybody has started their AI journey.
Fantastic. All right, so that's it for us. We have a few more questions, but I've leave those questions to the website, and maybe you can find some way to respond to them.
Yeah, I'll be online and let's chat on the platform.
Yeah, perfect. Awesome. All right. Thank you very much, Kari. And
Much.
it was a wonderful session, and we will look forward to other sessions today. Okay. Thank you, everyone. Have a good day.
Yeah.